we have done in forces and equilibrium. Now we are adding contact force to it. For example, there is a book on the table and the book weighs 6 newtons. So this is an equal and opposite force by the table upwards, that is 6 newton, and this is known as contact force, labeled as R in most of the places. Sometimes it is labeled as N also. And be careful when you have the object like a ladder resting against the floor at A and the wall at B. Contact force is always perpendicular to the surface, not the object. So it is perpendicular with the wall and it is perpendicular at A with the floor. These are contact forces. So in the first case, contact force R is equal to weight. Now if I say that the book is still there, which weighs actually 6 newtons, and contact force is upwards, which is unknown, and someone just landed a finger on the book and they're pressing it with a force of 2 newtons. So now the contact force would be upwards is equals to downwards. The contact force is 8 newton. The table is actually pushing it upwards with a force of 8 newtons. Similarly, if we have another case and same book is placed, this is 6 newtons, and we tie a gas helium filled balloon which causes an upward force of 3 newton on the book, and we know that contact force is also upwards, so we know up forces is equals to downward force. So R is equals to 6 minus 3. In that case, contact force is 3 newtons. Another thing which would be added is friction. Formula for that is going to be friction is equals to mu R, where R is the contact force and mu is the coefficient of friction between the object and the surface. Greater the coefficient of friction, greater would be the friction. And we will have mostly two cases. One would say, for example, we have it at an angle. This is the object. We can draw its weight. This is angle theta, and then we can split it up in two components. This is theta. This is going to be W cos of theta. This is W sine of theta downwards. And suppose we are pulling it up with a force. Now the two cases would be, it would say that it is at a point of moving up. So if it is at the verge of moving up, friction would act downwards. In that case, what will we do? We will equate the forces towards right, or say upwards, is equals to the opposite forces. So in this case, that is the pulling force F is equals to the friction plus the component of weight, which is W sine theta. And not forgetting that friction is actually equals to mu R, and some data would be given in question. Now this R needs to be replaced. Mu is equals to R is W cos of theta plus W sine theta. And the second scenario would be that this force is sufficient enough that it is at the verge of moving down. So if it is actually moving down, this force in red would stay there, but friction will change its direction and it would be upwards. So now we can say that friction plus the upward pulling force is equal to W sine theta, which is component of force, component of weight that is acting downwards. So whatever is unknown, and according to the given data, mu R plus the pulling force equals W sine of theta, and we keep on replacing and plugging in. W cos theta plus F is equals to W sine theta. Some of the data would be given, and this was R, which is equal to W cos theta, because these are the only two forces in this direction.